you. All right. Just a brief introduction. I have a lot of slides, so let's see how far we go. My name is Olaf. I'm a defensive specialist at Belgium Force. We're a company that does a lot of offensive work, a lot of detection engineering work. So, and the reason is also why I did dug into MDE. So it's one of the tools that we work a lot with. We want to understand, like up to a certain depth, what it actually does in order to use it to its full capacity.
I did all kinds of things in the industry. It doesn't really matter for now. I studied arts. I used to be a documentary photographer. Now it's a hobby, so it's kind of nice to at least get outside and away from my computer. And of course, I like warm hugs. If you want to reach out, there's some details on this slide. There will be at the end as well, or I'm around, so you can find me. So what can you expect from this talk? So I'll briefly highlight some of the capabilities that the Defender for Endpoint product has. I won't go into all of them at length, because then we would be here a very long time. We'll focus a little bit on the telemetry, so what does it give you, but also where does it come from, where does it gather it, and how does it actually gather it. And of course it has a configuration, so we'll dig into that bit a little bit. And then I have a sort of choose your own part of the rest of the slides. So I have two topics. It's either log augmentation, or it will be all kinds of timing issues that are happening within the product. So we'll get to that. We'll raise some hands, and if you don't make a choice, I'll do it for you. So first of all, some of the capabilities. What can you expect from the product? So it's quite broad, and it's a sort of mix of all kinds of either native tools on the OS already, or some of the ones that are actually shipped with it. So they have a solution for Mac, Windows, or Linux. Quality differs, but we'll focus on the Windows one now. So of course it has the AV component, which is already just a normal Defender agent, but it will gather that telemetry. There's attack surface reduction, which is a feature that it's quite nice. It's not perfect, but it's a useful feature that you should at least enable. We'll dig into that bit. There's exploit guard, which is the former EMAT, so it does some blocking of some suspicious activity. Then there is the Windows Defender application control, which is actually not a part of Defender. It's just enabled on every Windows 10 and up box. There's of course EDR telemetry, there's incident response capabilities where you can remotely log onto a machine, run some scripts, gather some memory, these kind of things. It's somewhat limited, but with some creativity you can do a lot of things. It also does some vulnerability scanning, and even some like network scanning. So it scans its own subnet, and then it figures out if it's at home or not. If it thinks it is at home, it will not report it to the portal, but otherwise it will. So if you're a consultant, you might be scanning some of your clients' environments. So keep note of that. Turn it off maybe. And there's some DLP capabilities that are in there. And as I mentioned, right, some of the things are already in there. You don't need a license for it, so you should enable those regardless of it. So the AV is probably the simple one. It's on every Windows box. It's enabled by default. You can think of it what you like. AV is something you don't really want to avoid. I guess it's very signature based, so of course it's relatively easy to bypass it. There's a lot of great research done by Camille from the ANSI in France, and he found a way to basically decrypt the whole database so that you can actually easier find what it's triggering on. So there's a lot of exclusions that you can do, and you should monitor this, because this is probably one of the first things that every malware tries to do, right? If it gets on the box, it will try to exclude itself and some of the other things. Keep in mind that if you exclude a process instead of a folder, that it will only whitelist the children of that process that you excluded, so it will still trigger on the initiating process. And these exclusions only apply to the AV. So every component of the Defender product have their own exclusion rules, which can be very useful, but it can also be very tedious. Just be aware of it. And there are all kinds of tools to see why it's triggering, right? So you have a tool called Defender Check that is actually being flagged as a virus now, so you can check Defender Check against Defender with Defender Check. So it's sort of a weird rabbit hole that you're diving into, but basically what it does is give you sort of a part of the code that it will trigger on. And quite often this is a comment or some string in it. So if you would be a malware developer, you could just alter the string a little bit, try it again and see if it's getting picked up. And it might be triggering on something else. And as a defender, this is also useful, right? Because sometimes you have developers in your own organization, they build a tool that might be perceived as a threat, so you can at least see where it's triggering on, ask them to change it, or you can, of course, also submit it to Microsoft and get it sort of passable, depending on what you want and depending on how long you want to wait for it. Other product which could be very interesting to you is the attack surface reduction rules. So there are like 16 rules that you can just enable. Palantir is a US company. They did a lot of research into what should be, for most organizations, achievable. Some of the things are like block JavaScript or VB script from Office processes, or Office processes loading child processes, and these kind of things, which in most organizations you really don't want to have. It's at least another hurdle for an attacker to bypass, and of course everything can be bypassed. I'll get to that in a second. But it's quite nice, and if you're not really that eager to put everything in block mode, at least put it in audit mode, because you will get additional events of some of the things that you might not have the telemetry for otherwise. So it's just a nice way of having it, and at a certain point you might want to actually start blocking some stuff. So as I mentioned, just enable it. It's really nice. The rules are written in Lua, and they're also stored in that Defender AV database. So the same guy also found a way to decode those. And basically, they're relatively simple, and I highlighted a couple because some of them are very lengthy and also not as great. So if you're a little bit familiar with regex or something like it, you can see it's basically looking for a subpath. So anything can go in front of it, and anything can go behind it. But if these two directories can be in there, are in that path, it will allow it. So every red teamer that knows this will just create two directories, put its thing in there, and it bypassed ASR. It might still get catched by the AV or by the EDR component, right? So it's not terrible. It's also not great. So Microsoft is also aware of this. This is probably just a sort of quick build that they sometime did and are trying to improve it. So they will also look at signatures in the future and all kinds of other variables. But for now, it's usually file name, the path, or a command line. All kind of things that are relatively simply altered. However, it's blocking a lot of the commodity malware, so that's at least great. Exploit guard is the successor to EMED, as I mentioned before. It can block all kinds of arbitrary code. It even blocks Teams, so also have to look at that. Not everything from Teams, so it still functions mostly. But you have to trigger this a little bit in your environment to see how effective it will be. It's not ideal. Same goes for Defender application control. This is a super powerful feature. It's really nice. You can do all kinds of fun stuff with it. It's primarily built as an application whitelisting solution or / blacklisting solution. So what you could do, for instance, is have a list. Microsoft even publishes a list of suspicious driver or no malicious drivers. You can just block those. It loads very early on the boot time, so you can actually do a lot of interesting stuff with it. If you're really creative, you can also break stuff. So definitely test this a lot of times before you roll it out. And the same principle applies as the ASR rules. You can make sure to at least audit everything first, and then maybe later start blocking things if you're like testing it out and rolling it out slowly. And maybe later we'll also look into how you can use this feature to enrich your MDE logs, which aren't always great. So towards that, there is a huge EDR component. It gathers basically it runs under the MS Sense process, which is a service that is running on every Windows box once you enable this license. And it will gather all kinds of telemetry from all kinds of places. And basically what the key thing here is everything that it gathers is basically configured by Microsoft. You have no control over this. It's a product that you buy, and they basically maintain it for you. So they choose which registry files are, or which registry keys are there, which files are monitored, which is whitelisted, which is filtered, all kinds of things. And the filtering is very important. So it's also mentioned over there. Some of the events are heavily sampled in different kinds of ways. So the network connections, for instance, they look at the first seen event. And the first seen event for them means over 24 hours. And that means that if a certain process with a certain parent and a certain source port and destination port connects to an IP, you will see that once every 24 hours. So that means that if you have a nice beacon running and it connects every 15 seconds or whatever, and with the jitter, you will see that once, unless there is another AV component that thinks it's suspicious, you'll get more telemetry, but not all telemetry. So that's something to be aware of. That's, yeah, it's not great, but at least you know it. The same goes for file write events, that is also heavily sampled. The most annoying one, I think I don't have on the slide, is the DLL loads, because that's just YOLO. It's really, there's no way to explain what it does. Even if I have 5 machines next to each other that do exactly the same thing. For instance, I have a Word document that opens a Word macro and executes something. On one machine I might have the VBE7.dll, on the other ones I might not. Why? I don't know. Microsoft can't explain it either. I tried asking them a couple of times, but there's no real rationale behind it. So that's a concerning thing. And then one of the primary data sources for all this telemetry is the E2W, so the event tracing for Windows, which is used by a lot of processes, right? So it's very rich. It even has its own set of ETW providers, and it also ties in the threat intelligence provider, which we'll go into a little bit in the 40 seconds. And everything gets shipped to the cloud. There's a whole mechanism with store and forward for it. And basically, it will retain there for 30 days as raw telemetry or raw sample telemetry. There's no control over lengthening that. You can't pay Microsoft extra or anything like that. And they also have a timeline of 180 days. And that's a huge difference there, because that is a sort of abstract of your already sampled data. So it's very limited. I don't really like it. It can, in some cases, be useful, but in most cases, I'd rather go through the raw telemetry. And if you want, you can, of course, extract it, put it into your Splunk or your Sentinel or ArcSight, whatever you want to use, and retain it way longer and do some additional analysis on it. On average now, I think it is a little bit lower. I think it's about 20 to 25 megabytes per device per 24 hours. So it's not a huge set of data. So it should be doable for most organizations. So what kind of data is in there? So as I mentioned, there's like image load events, there's network connections, there's all kinds of things. And they're stored in a sort of table-like structure. So you have all these tables, if you can actually read it back there. And then within the table, there's all kinds of fields. So there's just a schema set for it. And it's relatively easy to get that schema as well. There's a get schema command. There's also a schema reference. Oh, I'll go to that one later. And the interesting bit is they usually have an action type in there as well. So that's a sort of classifier within there. And in most of the events, it's just like network connection created, socket opened, these kind of things for the network events. But they also have the device events. And the device events is sort of catch-all bucket of everything that didn't fall into one of the other tables. And basically what you can find there is, if you look at that action type, there's about 185 different action types as of today, and they keep on adding stuff to it. And you can get your ASR events there, that if you have enabled them, or the WDEC stuff. But also if I plug in a USB device, or I don't know, what else is in there? WMI queries being created, name pipes, you name it. Again, they all have that same logic of the sampling, but at least you have a lot of rich telemetry there. And they also have a schema reference where you can just go through the GUI and read up on what they actually store there. It's quite nice documented. And the funny thing is that they usually have the documentation in there first before they actually enable the feature in the agent. So what we do is we use the hacker tab and basically get the local API call, which is of course undocumented. And basically with a very simple script, just grab the whole JSON file that they expose. And we do diffs on that. And then every couple of days, we get a nice Slack bot message where we can see, hey, there's new features. So of course, this is just useful because we want to utilize all the telemetry in there. I don't expect everybody to do this. You can also just scroll through it, but then you have to remember it. And my brain usually doesn't work that well on such large data sets. So might be great. We'll skip that. So out of the box, it also has all kinds of capabilities, right? And this is an old slide intentionally because I see some red teamers and there might be some malicious people in there. But basically, this is something that they won't disclose for all kinds of reasons. There's of competitors and there's, I don't know, marketing that doesn't like it because they don't have that actual full 100% MITRE coverage, who nobody can have. So we track this sort of by fuzzing and by exchanging it with some trusted parties. Just to understand again, where is it very strong, where is it maybe weaker, and of course there might actually be detectors for these kind of things that we didn't trigger, but at least we can do some additional research there, try to trigger it later, or build our own detection on top of this. So could be very useful. Again, this is very old, right? So it's very different now. And from there on out, we also want to understand a little bit, so what can the telemetry bring us? So there's an open source project called OSAM, which is created by Roberto Rodriguez and his brother. And I made a lot of contributions to that, where we basically map for every event that can be triggered, the data source components that are visible in MITRE ATT&CK. And what you can then do with that information, since there are groups in MITRE ATT&CK that have tactics and they do techniques, there are data components in there, and then from there we can actually start mapping that with the OSAM references so that we can tag it to the events within our product, so that we know a little bit at least where we could start hunting or build additional tools on top of this. And this is theoretical, mind you, but at least we can create a sort of telemetry coverage map here, where we can see what kind of data could we, according to theory, at least expect. And of course there are configuration issues and gathering issues, but at least we know a little bit where we can start looking. And for instance, for this process injection event, MITRE lists a bunch of data sources that they deem useful for you. And we can map it back to, okay, then we have to look at the device file events and the file modified flag, for instance. So it's just a starting point, and it gives you quite a large data potential, right? So we put everything into Neo4j, graphed it with a customized bloodhound, and of course this is unlegible. It looks pretty. But if we start looking a little bit deeper and say, okay, let's just see what the registry logging could bring us. And then you can already see, hey, we need these objects, and we can basically have these techniques potentially. So that's all nice and good, right? But then we also want to understand what is to actually get that telemetry, because having it is nice, but this is also something that probably will be tried to break, or at least an attacker will try to break that whole telemetry chain. So there's a couple of levels of where it gets it. So first of all, it has a kernel driver. And basically what that kernel driver does, and yes, I use Mimikatz to get this callback channels because that's a very nice way to represent it. But basically what a kernel driver does is it tells the kernel every time a certain incident occurs, tell me about it. And then basically it gets logged and stored and forwarded. But what you can see here is that for instance, for the process callback, you see a wdfilter.sys and you see an mssec.flt.sys. So that actually are two different components. So one is the AV component, which is on all boxes, and then the other one is the EDR driver. So they both have their own driver. They even have different configurations, what they do with the data afterwards. So if you want to tamper this, you also need to kill both of them, because otherwise it might still get some telemetry out. There's also a Sysmon one, if you see that. So it's actually doing the same. So this is where it gets its registry information, its thread information, its DLL loads, process creation, name pipes, and a couple of other ones. And another interesting thing is where you can also set a pre and a post operation if you have a callback. Sorry. And the big difference here is that the pre operation is basically process creation, the post operation is process termination. And the big difference between Sysmon and the other products, or one of the big differences, is basically that Defender only looks at the created processes. So you can't see a process lifetime within the Defender logs. That's basically then the result of that. Not used by a lot of people, but during forensics it's actually very useful. So again, I started mapping those just because I like graphs. And basically these two drivers do kernel callbacks, they go to certain objects, and then I could link them to the data components in Defender to be able to predict basically which tables I need to be querying for that data. Most of them are very verbose, so you already know by name, but it's just a fun exercise to do. So digging a little bit into the event tracer for Windows bit, the ETW. It's basically a tracing process that is kernel driven, where processes can expose data or they can subscribe to other ones' data. So that's where the providers and the consumers come in. And a trace session is sort of in the middle between consumers and providers. That it's a different methodology of gathering it. If you want to learn more, there's a lot of documentation written by Matt Graeber on this. But basically, you have to assume that somebody exposes data and somebody wants to get it. That's the basic gist of it, what we need for today. And interestingly, the MS Sense service also creates its own providers. And it's kind of interesting to see, so these are all trace logs. And Matt Graeber built a tool so you can easily get that for every executable that you're interested in, just to see, hey, what is it doing? Which kind of providers does it have? Or is it subscribed to something? These kind of things. So MS Sense has a whole set of them. And basically what it does on the background is it subscribes to all kinds of things, stores it in an SQLite database on disk, which is not easy to tamper with because it's a protected folder. You need quite high privileges to get there. And then it's also signed. So it's not the best way if you want to tamper with it. And it's interesting that the table is called Asimov events. And Asimov is a sort of Halo reference that is very old in 2014. That was there for the unified telemetry agent. So it's actually not a specific thing built for the Defender process. And it got replaced somewhere 20, I don't know. Later it got, at least later, it got replaced by the Diactrack agent, which is probably more familiar for some people. And basically what it does is it's just for a short store. So if it's connected to the internet, it will store it maybe for 20 minutes or something like that, preferably less. Uploads the data, and then it gets flushed. So it's a very short lifespan database. So it's not very useful for most things, but it's basically how it works. So that whole list of providers that MS Sense builds itself, I was quite curious to see what was in there, because I wanted to know what kind of telemetry does it actually ship to the cloud. So I used a tool called CLider, which is a very nice tool where a very simple JSON config, you can tell it which event tracing providers you want to trace. So I flicked them all in there, ran it for a while. It's really nice because you can give it like just console output, or it writes to a JSON file, or you can even write it to the event log if you want to ship it off later yourself. And the author mentioned that it's not very stable. I didn't have any issues. It's a great tool. And basically, there's a couple of providers. So even some of the MS Sense providers are protected. So you can protect them with the protected process light tab, which means that not every process, even a system, is enabled to add it or connect to them. And some are even higher, have a higher protection level where you need the early launch anti-malware, the ELAM driver. Which is also a PPL process, to access those. And the primary one is the Windows Threat Intelligence one. And this is primarily exposed for Microsoft authorized AV vendors that can actually utilize that one. You can, with a couple of tools, get there anyway, but you need to fit a little bit. This is also how we found a couple of CVEs within the Defender product where we could spoof arbitrary data into the whole process, which is fixed, fortunately, because they did a sort of unauthorized data gathering. So you could just send anything to a certain tenant with a specific code that you could gather from every machine, and you could add additional machines, just generate random alerts, and give the SOC a fun time. So that's fortunately gone. But looking at that data, you get a very nice JSON structure. There's all kinds of stuff in there. And of course, there's an event, which I found very interesting. This is the tale of the cyber events. They have very creative names. And this looked a lot like Base64. So I was very interested to see what was in there. I basically decoded the whole thing. We get some gibberish. And then we get something that looks very familiar for a lot of people that ever looked at an event log. Even the ugly tabs are in there. So it's just a raw dump of a PowerShell log. And this is a very simple example, but you get the gist. There was also some binary data around it. And this is Bond. So Bond is an open source tool that of a platform, which is created by Microsoft to basically serialize data. And they serialize it with a schema. The schema is somewhere, probably in the source code. I looked for it a little bit, but I really couldn't be bothered a lot because I could just read. That was enough for me at that moment. But the interesting thing was then, hey, I see PowerShell events. Where does it get it? Because it looks like an event log. So I opened up Telemetry Sorcerer, which is another very useful tool where you can just see all the providers on your box and the processes that have a subscription to it. Mind you that you need to run it as system to be able to see all of the subscriptions, because sometimes otherwise you'll miss a few. But what's interesting to me is that you see here the PowerShell one, and the only subscription to it is actually the event log application. So does MDE then look at the event log as well? Well, it was kind of interesting. And to explain this a little bit more, we go back to that DiagTrack service. So DiagTrack service is actually to get all kinds of telemetry, also to Microsoft of your usage and all kinds of things. So there's a lot of blogs about people telling you to disable it. It is unprotected, so you can basically just stop it, pause it, do anything to it. It used to be protected for a while. I actually found a Black Hat talk from 2017 that also found some stuff on this service. And right after that talk, it became a protected service. But for some reason, or regression testing didn't work, but at least it's not protected anymore. So if you disable this as an attacker, there will be some telemetry missing. This is primarily the ETW gathered telemetry, so all the kernel driver stuff will still flow into the portal, which is mostly used. Right? That's the process creation, network connection, registry, and so on. But there will be some blind spots, so be aware of it. Monitor the servers, try to protect it if you can. So it's quite an important one. So we'll hop into the configuration bit a little bit. And like every product, Defender needs a configuration to run. The configuration, as mentioned, is by Microsoft maintained and gets basically downloaded every, I don't know, hour, 30 minutes. It's stored on the box somewhere. Go have fun finding it. I won't tell you where it is because there's a lot of information in there that is also very useful to attackers. It's very easy to bypass it if you know what it's looking for. But if you want to have a sort of idea what's in there, there's all the ETW providers with all the events it's looking at and which fields it's getting it from it, which registry keys it's monitoring, which file paths, of course all the exclusions and filters that it applies to it. And on top of filters, it also caps, like I mentioned, right, the first seen events. And then all the scripts that it uses for dynamic data collection. So for instance, which Wi-Fi connections you've connected to, all kinds of file stuff, running services, and so on. And then all kinds of agent configurations. So also if you're on a low latency connection or high latency connection, it will do different things to ship to the cloud. And it's about 70 to 75,000 lines of JSON code. There's 65 ETW providers, 500 registry paths, 60 of those scripts that I mentioned, and all kinds of quotas to optimize it a little bit. So looking at those ETW providers a little bit deeper, there's as I mentioned, a long list. So a couple were interesting. So the threat intelligence provider is very interesting. I'll show you some examples of that in a second. So the PowerShell one, it's called a little bit different, but we just seen that. And I also saw SecurityW, which sounded fun. So I was interested in that one as well. But first, that threat intelligence one. So that actually looks at a lot of API calls that are used by all kinds of things for process injection or memory dumping and so on. So there's a long list, basically, of events that it will gather and that will be processed and shipped to the portal. So this is a very useful one. And it's also very hard to tamper with. I don't know why I have it twice, but going back to that SecurityW one. It had a fun name, so I was interested in it. So I looked up the GUID with Logman, which is a local tool on every Windows box. And it turns out it's just a security log. So that's interesting, right? Because everybody knows that one. So looking at the config, I was just digging through it. There's some SID filtering that it filters, but basically, for instance, it looks at 4624, which is a successful logon event. And then basically what it does is it has a sort of config of that local cap that I mentioned, right? So you see a target username, a domain name, a SID, a logon type, an IP address, and a target logon ID. So if I log on with those parameters to one box, and I do it 20 times, I'll see it once every 24 hours. But it's not in this one, but it's always 24 hours. But if I log on to multiple boxes, I'll get multiple events. That's basically how this works. And there's a total of 1,000 logon events per 24 hours that is stored for that machine. And this is for a workstation, right? Servers sometimes get a different configuration, because if you run this on your AD, it's a bit useless. And then you have a field configuration, basically, for every field, what type of field it is, how it should be parsed. Sometimes they do all kinds of fancy enrichments with it. So you can basically understand a little bit what type of data you would expect on the back end. So, since it's looking at security log, I was interested in which event IDs does it actually look at, because some of the event IDs are not enabled by default. You need an audit policy to actually be able to utilize it. So this is the full list, which is quite a lot, right? It's very useful data. So I started looking at, okay, which audit settings do I need for this? So there's all kinds of reference material online, so you can basically find which audit category and actually which settings you also need. So there are basically 3 settings, or none, which is number 4, which you can set. So if it succeeds, fails, or does both, or you don't enable any auditing. So basically, if we flag those and then start looking at a default Windows 10 box, and match it with the required settings that MDE has, there's a lot of stuff that you can't read anymore, because that's fine, right? These are enabled. But there's also quite a long list that you still can read, which is now not enabled. So MDE won't get telemetry for that. And some of them, like service install, it's quite often used by the attackers, or scheduled tasks, plug-and-play stuff. Firewall I sort of get. So that's not great. So Defender also knows about it, or Microsoft. So what they do is they enable a bunch of them for you. And they keep some out, right? Like firewall logs, of course, very noisy. If you do this on a machine that also logs to a SIEM, you're gonna have a bad time. So that's why they keep that off. And that is fine. The terrible bit is there's no documentation for this. So if you don't know this, or accidentally have a policy that has some of that enabled, you're lucky. If you're not, you have a problem. As well as if you have a group policy that has a different setting than what they now did to your machine, because that will override it, and it will keep on overriding it. So if you have a policy that does something else, you need to fix this. So this is basically what I just said. So definitely make sure to check your GPOs, and this can be a quite annoying job. So I tried to code a very shitty PowerShell script to basically get all the GPOs. You need RSET on it, so you need to have some administrative privileges. But basically it checks all the GPOs, looks if there are audit settings in there, and then checks if the setting that MDE requires is set to the proper thing. So if it's over provisioned, it's fine, it won't notify you. If you don't have anything set, that doesn't necessarily mean a bad thing, right? The domain controller policy in some cases might also get another one. So you need to know a little bit of your structure. And then if you have a very bad one, it will tell you, hey, the expected setting is X and you have Y, so fix it. So we have about 10 minutes left, and I have 2 topics to discuss. So either, and I want to raise of hands, so I have telemetry augmentation, so all the blind spots or some of the blind spots can be fixed. So I have a solution for that. Or there are all kinds of issues with timing, ingestion time, scheduler times, all kinds of other things. So who is for the first? All right, and the second? Okay, sorry for the first, or sorry for the second. What's that? Well, it's 25. All right. Well, maybe we do both. I'm quick, apparently. Thanks. So first, the telemetry augmentation. So we've seen a little bit about Defender application control, right? So this is, it's quite interesting. Another example that I had before with the Word documents, this is if you load .NET code. So there's a couple of DLLs that always get loaded if you don't load a .NET app. I checked this on a lab machine that I have over the last 24 hours, and it was nothing. So that was disappointing. And then I figured, hey, there is actually the code integrity policy audited, which is basically another name for the WDEC stuff. The event log itself is also called code integrity. And if it's audited, it detected that it actually had a violation. So I figured, hey, why not create a config that has all kinds of violations for the DLLs that I'm interested in? Because then I at least get, again, just one per day, but I at least get results now, right? So that's actually kind of useful. And basically, you get quite a lot of information. So I sampled it here only to some of the basic variables, but you also get the signature information and some of the other. It's quite a rich data set. So, as I mentioned, so policies can be enabled in an audit mode or an enforcement mode. So if you put it in enforce, every time it tries to load something, it will just kill it, or not allowed to load even. So it won't kill it. It doesn't even get the chance. And the cool thing is you can also use this in mixed mode. So you can have a policy that blocks some of the stuff you're actually scared about and have this as an additional layer on top of it to just get additional telemetry. And it's a super powerful tool. So you can also do all kinds of COM object blocking. You can do all kinds of process injection monitoring. So it's a really nice one to start playing with. It is very fiddly though. So it's and it does require you to have a really good grasp on your machine. So if everybody has local admin, then forget about it. You won't be able to use the enforcement mode because that will be so messy, and you won't be able to really use this. And as one of the protective measurements, because of course if you're a local admin, you can just override the policy, refresh it, and it's gone. You can sign the code. So if you load it first and there's no attacker on your box yet, you can have a policy that is actually signed, and then it's very difficult for them to override that one. So keep a note of that one. And basically what you can do is you can configure it in a lot of different ways. So you can do it on hash anyway. The ones I use most is the file name and the file path, because I'm interested in DLLs and they have some attributes. I don't want to do it on hash because then I have to do it for 50 different patch levels. That's going to be messy. So it's not a perfect solution, right? But it looks at the original file name actually. So there's a couple of useful things there. So if an attacker renames a DLL and puts it somewhere else and loads it, I'll still see it, unless they also modify the PE header, which will kill the signature and will still catch it because it also doesn't allow unsigned or not validly signed code. And again, I don't block it, so nothing breaks, but it is kind of useful there. And keep in mind that if you start building a policy like this, that a lot of developers, even at Microsoft, don't always adhere to the right way of doing it. So for instance, even the AD Explorer, which is sysinternals, but sort of Microsoft, the original file name is called ADEXP and not adexplorer.exe. They do it consistently for the 64 and 32 bits, so you still have to only add it once. But the same goes for DLLs. So if it's the 32-bit and a 64-bit DLL, usually the original file name is the same, so it's relatively simple to configure. And basically, if you build a policy, make sure that it's in audit mode, because otherwise you break stuff. And then you can just have a very lengthy, ugly XML file, where you have to give it a ID, and basically, you can give it a friendly name that's just nice to have a reference, right? And then you can block all kinds of stuff, like scrubj or MC, whatever. So you can at least see if something is being loaded. You can use wildcards, but you can only use them once every line. So in this case, for instance, yeah, you can have some nice variables like OS drive or removable drive or WinDir. And then you can use one wildcard. So you can't say it needs to have these folders in the path, because then it won't work. And then you need to convert that XML to a policy file, which is a binary object. So the easiest is with the wizard. You can just click through it, it generates it, it gives you a GUID named binary file. You drop that in the Windows folder. you reboot or refresh the policy, and it's done. There is some issues when you start coding, and sometimes I make mistakes. The wizard just generates a file, it says, but it doesn't write it, so then it doesn't give an error either. So again, Matt Graeber built a lot of tools, and he has a lot of documentation on this, so it's way better than the Microsoft stuff. So he has a tool where you can basically build it, and he gives actually really nice errors. So I had a typo here, and I did something else there. I had an empty deny rule. So these kind of things, he gives errors or messages so I can actually fix it. And then you can also build it with his PowerShell tool. So it's a little bit harder to use for some people, so that the GUI might be nice if you don't want to edit it too much and don't make mistakes like I do. And otherwise, just use this, which is really, really nice. So I created a small Git repo. I think it should be open now. And basically what I did there is I built a very lengthy XML file with, I don't know, 115 something rules of files that I at least want to have telemetry for. And this is definitely not complete, so feel free to add stuff that you think is very useful. There is one limitation, sort of, is that the stuff is capped to 500 events per machine per day. But keep in mind that is first seen events. So if, for instance, there's a C script binary that constantly loads mc.dll and some of the other things from the same initiating process, which is actually Defender. So you only get one event a day. So it doesn't really flood it. So it's still very valuable. But you also need to sort of know then what is expected on your box and what isn't to be able to build some additional useful rules for this. So as I just showed you, that .NET stuff, it's just a couple of lines of code. And what you can then also start doing is build on your enterprise network. You probably know, or hopefully you will know at least, what are the most .NET binaries that you would actually suspect. So you could build a rule like this, where you have a sort of array of the binary names and the folders where they are at. And you can start excluding those from your search results and just start looking at, hey, what kind of .NET binaries are running on my box? And in this case, it was like a small set that all run sort of from a couple of directories, and then there was Teams, of course, which also at some point decided to update. So at a certain point, you will have a relatively simple baseline, and you can start looking at that type of events. So on most of the machines with the config now, I get about 200 events a day. So still I have 300 of space, which is quite all right. So some of the things that you need to keep in mind if you want to start using this, as I mentioned, it's one a day. The field names are sometimes missing. So for what's currently not there is the original file name of the loaded file. So if I rename, I don't know, one of those DLLs that we saw before to something else, I get the event, but I don't really know why it triggered. So it's not great yet. They're working on this. I reported it to Microsoft. There's a ticket for that. So in the next couple of weeks, it will be fixed, hopefully. So that's the only downside yet. And one other one is, of course, it only works for drivers, DLLs, and executables. So for binary files, basically. That global cap, and then basically what you definitely want to do is see if people are changing the policy. If you're not doing it, somebody else is fiddling with it, giving you blind spots, or blocking stuff maybe on your box. So that was that. There's also a lot of people that use Sysmon. I tried to make a sort of comparison between the two, and of course there are many differences, but these are probably the biggest pros and cons from my end. So on the Sysmon side, for the people that don't know it, it's a free tool created by sysinternals that allows you to run a config and get sort of similar telemetry. So biggest benefit from that one is you have full control over the config, right? You can do anything you like with it that it's capable of, and you will get that telemetry. In my opinion, it's best applied next to MDE in a sort of augmentation mode. So if there's certain registry keys that you really want to see, or DLLs, I'd only look at that, because otherwise you're generating so much additional telemetry that you really can't store maybe. It's a cost thing. So it's very rich. There's all kinds of metadata around the files that you're monitoring and so on. Everything is tied to each other via a global unique ID. So it's really nice telemetry. But you have to maintain that config yourself, or you use an open source one. That's up to you, but then you might have also stuff that you don't know about. And it only detects, right? It can't intervene, it can't block anything. It just generates information, stores it on your box, and you need to get it out of there yourself and build the detections on top of that. So just if you're okay with that, you have the capacity for doing it, definitely go for it. And on the MDE side, it's fully maintained by Microsoft, which is a pro, but also a con, because you don't have any control over it. It can detect and respond, right? So it can kill stuff if it finds it in time. Sometimes it says it killed it, but it ran anyway. But that's the case with a lot of the EDR vendors, where they ship the data to the cloud, then it gets processed, but in the meantime, that process is already running, right? So it can't always be super accurate. Downside is that the configuration is locked, and there's a lot of sampling on the telemetry. So that's sort of the high-level view. And if we start looking at, I'm not sure if this is readable, but there's a couple of differences from a Sysmon perspective. So this is what Sysmon can do, right? So they have 26 event types, all kinds of things, network drivers, normal drivers, and there are some difference. So the gray stuff is what Sysmon can do, but Defender can't. So that's less relevant to compare. Some of the other ones are primarily where their data from Sysmon is richer and unsampled. And some of the other ones are sort of missing. And then the process tampering events is interesting on the Sysmon side, which basically shows herpderping and some of the other in-memory overrides. That is not visible in Defender for endpoint, but it's logged and it will alert on it. You just don't see the telemetry. So that they're sometimes exposing not all the data that they actually gather on your box, which is a shame. There are some unique features in Sysmon where it can capture clipboard events, which is very useful during an IR incident, for instance. It can save deleted files. Again, only use this very carefully, because it will also flood your disk if you don't configure it well. And on the Defender side, there's basically that whole device table thing of over 180 things that it can do in addition, which Sysmon can't. So it's not really apples for apples. And from a telemetry perspective, theoretically, the MDE one we saw before, Sysmon looks sort of similar, but this is a theory because it depends heavily on your configuration and also a little bit on performance, because if you enable everything, you'll get a lot of I/O, a lot of CPU usage, so sometimes you really don't want that. So it's not always possible, but keep that in mind. So wrapping up, or not, but at least try to understand your tools, know what they do, how they work, where they get their telemetry, how they can be bypassed, but also where your blind spots are. Because if you know those, if you're serious about your detection strategy, then you can get a separate product, shout at Microsoft to fix it, all kinds of things. But if you're not aware, then you're not utilizing your product. It's like the GPO's problem. Make sure that you have the right settings so that your product is actually used to the full extent, and then start looking at the next tool, right? So don't try to do all the things at once, because then you'll probably end up doing them poorly. And this is also a very important one. I'm now talking about MDE, but I've analyzed multiple EDRs, and they're sort of similar. There are all kinds of similar issues. Some is better than the other at certain thing, but then the rest is miserable. So keep that in mind if you start looking at these. So how are you for time, Chris? We're done? 10 minutes left. All right, maybe I can do this. So time. And time is definitely not always on your side here. And that's the thing with a very bad joke, but still. Another thing is that UTC or it didn't happen is another thing in sort of detection engineering, right? That's fine, the time zone works. That's not the worry here. Now we're talking about all kinds of delays, but also some other problems there. So, as we mentioned, right, the data gets gathered locally, it flies over the internet into the cloud. all great. But yeah, it doesn't happen like this. It doesn't happen within a couple of seconds. So the should happen behavior is it gets generated, it goes through that MS Sense thing, it gets stored in that database, and then at a certain moment, either that buffer is full or there is a sort of time trigger, and it flushes it sends it over the internet to the cloud. So that's like, yeah, best guess between 5 and 20 minutes. That's what should happen. So the actual what actually happens, it can be all kinds of things, right? Your machine can be offline, the portal might not be reachable, which sometimes sadly happens. So it can be maybe even over an hour that we have the delays. And then we have another thing. So this is basically the ingestion. You don't need to worry about the query. But what I did here is I looked at all the tables that we saw before, and I calculated the percentiles in 75 till 99 of the table with the difference between the previous bucket. Between the ingested moment and the generated moment. So the generated is when it was actually generated on the box, and the ingested one is basically when it arrived in the cloud. So as you can see, it's not all the same, especially if you move that way. So there's actually difference between the tables. So some of the tables come sooner than others. And this is a problem if you start correlating data, right? So if you're looking at, I don't know, a file creation event and a process event, and you do that every 10 minutes or 20 minutes, there might be a 30-minute gap there. So that is a problem. And this is in the lab. So then I thought, okay, how does that look in a production environment? So this is a relatively sizable client. And here it looks a lot worse. So if you do a 99th percentile, it's a lot of minutes. So that's several hours. And that, of course, is not fair, because there's all kinds of ways of reasons why some machines don't check in regularly, these kind of things. So if you start looking at the 95th percentile is probably relatively acceptable. You will always have some blind spots. But then you already see that that's like the 25 minutes till, 47 minutes. So there's still a gap between the tables, but everything at least comes in within an hour. But why does this matter? So there's a lot of reasons for that. So a lot of the rules that you find on the internet, and also what Microsoft published up to a certain point, is it looks at the time generated field. So you basically start a query by defining the scope of your data set, right? So you tell it, okay, I want to look at what happened in the last hour. And this is what then happens. So the machine generated an incident or an event on a certain time. It basically flies to the cloud. It's ingested at an hour and 10 minutes later. But you have your schedule running every hour as you configure it, because you're looking at an hour back. You don't want to have duplicate data, because then you get duplicate events. But basically, it falls in this slot. So this one ran, and it basically failed because that event was at a different time. So here, it won't detect it anymore, because this looks at the data from 2 to 3, and it was generated at 1:30. So that's an issue. So a better way of working, and try to do this if you use Defender, is look at the ingestion time. So the ingestion time is basically a hidden field in every event, where it shows you when it was actually ingested in the portal. And if you do that in your query, and it runs every hour, it looks at the data that it received within that time frame, right? So it doesn't care about the generated one, because it looks at the ingested one. So if it was ingested hours later, it will still fire, because the data is ingested within that bucket that you have. So it's a more reliable way of doing it. Microsoft also agrees, mostly. So they also changed their documentation at some point. They store everything in Git, so it's very useful when you see that they actually changed their mind. This was also an issue for their EDR component. And I emailed them about that I found it concerning. I didn't report it through MSRC yet. And they basically replied with, hey, we can't reproduce this. And nor could I, because they fixed it. But they didn't really tell me, so you're welcome. So that's one thing. And then there's another consideration. So if you schedule a search within the portal, it automatically puts some additional rules on top of it, where it sets the look back of your time frame. So if you schedule it for an hour, it will get the data of the last 2 hours. It's just how that Custo engine works. And the same goes for the rest. So there's a sort of incremental change. So if you want to look at the data of the last 24 hours, you need to run it every 12 hours. So you can't look at the data of the last 24 hours every hour, which is a limitation. It's not ideal, because sometimes you want to reference what happened on the whole day on a box. So you have to basically build 2 queries to sort of mitigate that if you want that. So if you build a rule that triggers every hour, you have to basically, your coverage will be between the 96th and the 97th percentile, if you want to achieve that. So then, but you still will have some missing data, because some of it, for some reason, comes in very late. So that's annoying. And then there's another annoying thing. So if you schedule that rule to run every hour, you would expect it to run, I don't know, if you set it at 1, to run at 1, at 2, at 3, at 4, and whatever. What actually happens is it runs at 1, then at 104, 204, then 307, and so on. So it's all over the place. And you might think, hey, what's 6 minutes or 5 minutes? But that's 10% of your data. So that's quite annoying. So we started to profile this, and we created an alert that always triggers on the oldest moment in that data set of that hour. And we started baselining that over a month. And basically what you see here is, this is what we scheduled. So this is what we expect. And the orange is actually when the scheduled run ran. So as you can see, there is maybe once or twice that it actually did it in an hour, over a month. So that's not great either. So on average, it's like 65 minutes. So that's 5 minutes of 60 minutes. It's quite a large percentage. So why not just use something to get all data then? Just get a lot. But then Defender gets mad at you because you use... So they don't do this anymore, I think. Sometimes you actually get 400%, but I missed to get a screenshot there. But that might also lock you out from doing additional queries. So you have to be sort of conservative with your use, because you're running on a shared resource cluster, so you get allocated resources every hour. And if you go over that, then the detection fails, so you have more blind spots. And then you might say, okay, well, if we run every hour, we'll just look at 2 hours, and then you're fine, right? You have that coverage, which is sort of true, but you get duplicate alerts. So Defender fixes that a bit. If you are not that quick in responding to your alerts, if it's still open, it will add to it and you won't get a duplicate alert. However, if you're a little bit more efficient, like a lot of people are, you closed it and then it will get you a new one. So that's very annoying because you just handled it, and if you get that for multiple boxes, it's a mess. So we started building a whole deduplication engine, and basically you can do this only on the device name, the account name, or the UPN. If it's a mailbox, that's just a limitation of Defender right now. And I'll go quickly through this because it's a lot of Custo, and I don't want to tell you everything because it's just very lengthy. But basically what we do is if we want to look at we always double the time that we actually need. So we tell it, okay, we want to see an hour, but give us 2. And then we set a deduplication field where we want to deduplicate on, and a rule ID, so that we know where we deduplicate against. Then we build a rule, right? We look at the ingestion time, blah, blah, blah. And then we basically look at we add a deduplication entity to our rule, so that we have a reference field that we can use now. And basically what we now do is we do look at the alerts that were triggered in the same time frame as we're looking at, so in the past 2 hours. And we look at the same rule name and then same device ID. And then if it's there in the time frame that we're already looking at, we remove it from our results and we only report back to the engine the stuff that is remaining or not, right? So basically what we do is we crudely deduplicate, because we can't do it on every entity, but this is the only reliable way of doing it. But this is very inefficient, because we're doing a lot of, this is all additional query logic, plus we're looking at more data for a problem that Microsoft can easily fix by just having that ingest time in the lookback period. So if it just will give me the last 2 hours of data that was actually ingested instead of what was generated, I wouldn't need to bother with this. So that's another ticket that is running. Another thing that you can still do is timestamp a little bit. It doesn't always work, and it's kind of funny because they now added a process creation time field. So you can see I tried to go way back, and we tried also in the future, but it overrides the timestamp because it's connected to the internet. It also, the Defender agent itself knows what time it is, and if it sees something being generated actually now with a process creation time that is not now, it will try to compensate for it, but it doesn't always work. So if you're timestamping, yeah, you may have varied results. So wrapping up, don't use the where timestamp or the where time generated. Use the ingestion time always in every rule. If you're hunting, it's fine, right? If you're hunting, you're looking at a broad data set anyway. Then missing 5 minutes is less of a problem. But still try to just make it a best practice for yourself or build a function for it. It's a waste if you're creating blind spots for yourself. Look at the ingestion delay, right? So make sure, because this applies also in Sentinel. So if you have data sets that come in every 4 hours and you run your detection every hour, you will have all kinds of missing events. And we tested this at a couple of clients, and they actually had a small percentage of events that never triggered, which could have triggered when we added this. And make sure to deduplicate your alerts, because otherwise the SOC will hate you. And then it's the same wrap up. So that was actually it. If I still have time for questions, I'll take them, and otherwise I'll be getting drinks. All right. Thank you.
All right, thank you very much. Very interesting content. Thank you for your contribution. I mean, coffee break is now, but if you want to stay for a couple of questions, then of course feel free. Otherwise, you are free to go to the coffee break. So, are there any questions?
So in regards to the sampling and the caps per day, is that filtering being done on the endpoint or on ingest? And if so, how would you write detection logic that's based around like event volumetrics, like password spray or Kerberos, or something that requires seeing a large volume of a certain number of events that may be capped? Thank you.
The sampling and the limitations are being done locally because it's primary bandwidth constraint that they want to keep it within, but it's also that they don't want to store too much information in the cloud because you pay a fixed fee per endpoint. So it will do it local. However, it can sometimes cheat a bit by using, for instance, the network protection sensor, which is part of the AV, and that will get additional telemetry there. So to that end, and like a password spray. You're trying to authenticate with multiple usernames. So that will be a difference in that fixed set of field names. So that will actually get you all the events. If you try multiple passwords with all those users, you will get one, right? So you get it for each event will be once for every user that you try if you are hammering against one AD. Or domain controller. So if you do multiple domain controllers with multiple users and do it in parallel, you might get more, of course, because then the destination is also different next to the user object. And I think Kerberos thing is slightly different because there's no real detection for it. The only thing that you can see is that you talk over port 88 towards the domain controller to get that ticket. So that will be more difficult because then you see a single connection. If you do it from an injected process and you didn't inject into ELSAs, which you probably wouldn't do, then we see it, right? So then you only see it that way. You don't see that you Kerberos it, but I see that you did Kerberos. If that answers your question. Welcome.
All right, one last question. That does not seem to be the case. All right, cool. Thank you again.
All right, thanks guys.